Welcome to Module 3. This is a video on user-defined function practice. So we're going to write a couple of user-defined functions and then practice calling them. All right, so the first function we're going to write is going to be a function called, let's get a pen here. This function is going to be a function that, first I'm going to put we're going to write the function definition first. So I'm going to describe what it does. And this is a function that displays game rules onto the screen. Displays the rules for a game, of a game. All right, so we're going to name this function. The name of the function is going to be rules. And this function is not going to take any arguments because it's just going to use a series of printf statements and printf is available throughout a program. And it's not going to return anything because it's not going to make any kind of a calculation or anything. So it's going to have a void return type and take no arguments, and the name of it is rules. And what this is going to do, it's just going to put a series of printf statements in which it describes the rules of a game. Now, of course, I'm not going to sit here and have you watch me write the rules of a game, but basically you could say welcome and put another printf that says here are the rules, etc. So this is basically just a function that's going to print a bunch of printf statements, but we're going to remove those printf statements from the bulk of our program or our main program so that we can focus on doing the other work, and you can take all of these printf statements, which could end up being quite a few statements, and put them into a function below the main function. So let me show you now how placement of this is going to go in the function. So keep in mind that this is the function definition. This is the function definition. And on the next slide, I'm going to show you where this function definition is going to be placed. All right, so now I'm going to do my whole main function, and we're going to set it up. So at the top of my function, of my program, my whole program here, I will have the header with these are comments, lines for comments, with the name and the date and the description. So this is just the header that describes the program that I'm doing. Below that, I will have my preprocessor directives, and one example of a preprocessor directive is #include stdio.h, which allows me to use printf and scanf. Then below that, I will have my function prototypes. Now, function prototypes describe what the inputs are to the function and what the function returns. So far I have one function that has a void return type. The name of the function is rules, and it takes no arguments. So this function prototype just allows my program to be able to use this function. It kind of describes the library, the prototypes describe the library of user-defined functions that are available in my program. So if I was using a bunch of functions, I would have more prototypes here. So then in my main function, which is next, I have my main function. Let me see if this, okay, next I have my main function. So in my main function here, I can make a function call to the rules function, but let's just set up my main function first, which has a return 0. And then below this is where I would place my function definition. It's very clear how this setup is. So the function definition that was on the previous slide would then go below this, and that would be the definition or the implementation of the rules function. Now, in order to call the rules function, to make any function call, you put the name of the function, and you put parentheses and a semicolon. All functions are going to be in that form. The name of the function, parentheses, and a semicolon. Now, if the rules function were to take arguments, I would put those arguments in here, but the rules function does not take any arguments, so therefore I leave this blank. If the rules function had a return type other than void, then this would be in the form of an assignment statement. So since the rules function does not return anything, then I do not need to put an assignment statement or have a variable prepared to capture what is being returned by the rules function. On the next slide, we're going to do another function. Here's doing functions. You want to start with the definition. So this is we're going to describe what the function does. So we're going to write the definition of a function that takes one integer argument and then this function is going to ask the user to enter a number and it will multiply that number by the argument of the function. It will multiply the user number by the number that was passed to it, by the argument number, and then return the result. All right, so let's take a look at what this is going to do. First of all, we're going to name our function. So let's name our function simple calc for a simple calculation. Obviously, this is a very simple, something that doesn't really need a function in order to work. However, each time the function is called, the integer argument could be different, so therefore the results could be different each time. In addition, this is just function practice. So this function is going to take one integer argument, so we'll call that int arg1, and this function is going to ask the user to enter a number, multiply the number that's been entered by the user by this value that's at this argument 1, calculate and return that result. So in multiplication, if you multiply an integer by an integer, usually the result would then be an integer. So now let's see what happens. So this is the function definition, so we need to figure out how to implement this function. So we need to ask the user to enter a number, so we will say printf, enter a number, and then scanf, since it's an integer, it would be %d. Now, we don't want to scan into arg1 because we want to use arg1 in our calculation. So we need to declare a different number to scan into. So we will scan into num. So we're going to get a value for number. Say we got the value 10 for this number. And say arg1 came in as a 5. So what would happen is this simple calc function would be called. Arg1 would get declared. It would say, like saying int arg1 equals 5. So arg1 is a 5. We get a number from the user, which we get a 10, and then we want to multiply these two numbers together and return the result. So how would we do that? Well, there's a couple ways to do it, but the most straightforward way to do it would be to declare a variable to store the result. Then we would calculate the result. The result would be made up of the num that was entered by the user multiplied by the number that came in as argument 1. Oops, I want to do that. And then we would return that result. So this is a function definition. This function is called simple calc. And what this function does is it takes one integer argument, asks the user to enter a number, multiplies the user's number by the argument number, and returns that result. And this is exactly what this simple calc function does. So on the next slide, I will show you the placement in the program and how to call this function. So if this was my program here, and so up here I would have my header comment, which is the name and the date, etc. Then I would have my preprocessor directives, and one of them is #include stdio.h. Then I put my function prototypes, and in this case I have a function. The name of my function is simple calc. This function takes one argument of type integer, and the name argument1 is optional on the prototype because all the prototype does is say that in order to use simple calc, you need to pass it one integer and it's going to return an integer. And of course, there should be a comment here that describes this function. So the description of the function should be there, and it should tell you that simple calc takes one integer argument and returns one integer, and then it's followed by a semicolon. So again, this is just a description of the library of functions that are available in my program. Below that, I would have my main function. And then below that would be my function definitions. In this case, I could put my simple calc function definition down here. All right, so how would we call this simple calc function? Well, in order to call the simple calc function, you would call simple calc with parentheses and a semicolon. So this is a function call. For all functions are called that way, but then you have to make a decision. Does simple calc take any arguments? Yes, it does. It takes an integer. Now, because when the argument comes in here and arg1 gets declared and initialized a value, the integer that gets passed here must have a value in it. So I can call it int num. And I can either assign it a value. There are different ways to get values into this integer. I'm going to assign it a value just to be simple, but I could ask and get a value for num. In this case, just because of space and time, I'm just going to assign a value, but I cannot pass an argument to a function that does not have any value at it, because actually what gets passed to this function is not the variable num, which in this case it is, but in actuality the computer is not taking the variable num as its argument. It's taking the value that num holds as its argument and assigning it to arg1. Then the next thing I have to look at is, does simple calc have a return type other than void? And yes, it does. It has a return type of integer. In the case that a function has a return type other than void, I need to have a variable of the matching data type prepared to accept the return of that function. So in this case, I'm going to declare a variable called result, and then I'm going to have an assignment statement that says when simple calc gets called and I pass it a 5, and then it does all of its work, and then it comes back, it's going to have an integer result. That integer result that comes back from my simple calc function call, this box has not code, it's just to say that when that comes back, it's going to be an integer, whatever the result of the calculation is, and that integer will then be assigned to result.